Hey Becca, what are we learning today?
Today, we're going to learn about coterminal polar coordinates. Today, we're going to learn about coterminal polar coordinates. I've drawn a situation where we have a polar coordinate of 1, 30 degrees. 1 is the distance from the origin, and 30 degrees is the angle of elevation. Now, in order to create a coterminal polar coordinate, we want to find another coordinate that will give us this point right here. Now, a simple solution would be to just take this angle, 30 degrees, and add 360 degrees to that, because that will give us a full revolution and take us right back to where we started. So a coterminal angle would be 1, 390 degrees. 390 degrees is 360 degrees more than 30 degrees. And these two coordinates are exactly the same because they'll lead us to this point. But what if I made the radius a negative number? When you make the radius a negative number, instead of bringing it out on the 30-degree line, it sends it the opposite direction, 180 degrees the other way. So now we have to come up with the angle that would get us all the way around to this line. Now we're just adding 180 degrees to the 30 degrees that we already calculated, because the negative radius sends it 180 degrees the other direction. So if we take 30 and we add 180 degrees, we get 210 degrees, and that will take us all the way to the negative value. So now 210 degrees around would take us to here, but that -1 would send us backwards 180 degrees to the 30 degrees. So this becomes a coterminal polar coordinate to 1, 30 degrees. In this example, we want to find a coterminal coordinate to -5, 45 degrees. Let's look on the plane where this coordinate will land. 45 degrees takes us in the first quadrant, about halfway. But our radius this time is negative, so instead of going in the direction of the angle, we're going to be traveling 180 degrees in the opposite direction with a distance of 5. So this becomes our polar coordinate. Now we want to find a coterminal coordinate with -5, 45, and we can make the radius positive and just find the angle that takes us from 0 degrees all the way to our coordinate. Since our original radius was negative, it went the opposite direction of 45 degrees, but by an addition of 180 degrees. So in order to find this angle here, all we have to do is take 45 and add 180. And that will give us 225 degrees with a positive radius. That's our coterminal coordinate to -5, 45 degrees. In this example, we want to find a coterminal coordinate to 3, 120 degrees with a negative radius. So let's look at where this coordinate lies on the plane. 120 degrees takes us into the second quadrant, and a +3 will take us a distance of 3 from the origin. So it takes 120 degrees to get to this coordinate. Now our coterminal coordinate is going to have a negative radius. So if we were going to make this negative, it would shoot the radius 180 degrees in the other direction. So that's going to give us a radius of -3. We just have to find the angle that takes us 180 degrees past 120 degrees. And if you add 180, you'll get 300 degrees, and that will bring us all the way around to the negative radius. We have more than one solution here because 300 degrees is also coterminal with a negative angle. How far away is 300 degrees from 360 degrees? This angle here is just -60, the difference between 360 and 300. So another coterminal coordinate would be -3, -60 degrees. This last example, we're going to find a coterminal coordinate to -3, 7 pi over 6 with a positive radius. If we graph this polar coordinate, 7 pi over 6 brings us all the way into the third quadrant, about here. But the -3 will shoot our radius back 180 degrees in the other direction. So our coordinate point lies in the first quadrant, and we need to find a coterminal coordinate with a positive radius. So we just have to find out what angle is over here, 180 degrees in the other direction. So we can take our angle, 7 pi over 6, and add 180 degrees, but we have to add it in radians. 180 degrees is the same as pi, and if we want a common denominator, we're going to multiply the top and bottom by 6, and when we add the numerators and leave the bottom the same, 13 pi over 6. So that can become our coterminal angle. We can also have a different answer. 13 pi over 6 itself is coterminal with another angle here. 13 pi over 6 is larger than 2 pi, which is 12 pi over 6. So if 12 pi over 6 is right here, and 13 pi over 6 is over here, the angle that forms between them is just the difference. And 13 pi over 6 minus 12 pi over 6 is just 1 pi over 6. So that is another solution to a coterminal coordinate.
Thanks for watching my video on coterminal polar coordinates. I hope you found it helpful, and if you did, you should give it a thumbs up and subscribe because I'm posting new videos every Monday and Thursday. And if you'd like to stay up to date, make sure you follow me on Twitter in the description at The Fear Factor. Have a great day!